All right, hey everybody. Today we're going to talk about a lesson on solving absolute value equations. Before we dive into actually solving the equation part of it, let's talk about absolute values a little bit first. Okay, if I'm telling you to find the absolute value of a number, okay, what are we actually finding? Okay, and just so we're remembering, okay, these bars, okay, represent finding the absolute value of something. So this is the absolute value of 3, and this is the absolute value of negative 3. Okay. So what is the absolute value of a number? Okay, it's pretty simple. It's basically just the distance from 0. Okay, so if we have a number line real quick, let's start, go all the way to 3 and negative 3. Okay, we have these values here. How far away is negative 3 from 0? Okay, and the way I like to visualize it is thinking, well, I'm moving 1, 2, 3. Okay, it's a distance of 3. It's 3 numbers away from 0. Same thing for positive 3, right? It's 1, 2, 3. 3 numbers away from 0. Its distance is 3. Okay, and another thing, and it's important that we're saying it's distance from 0 because distance is non-negative. Okay, even if I'm saying like, oh, I'm going to go 3 feet behind me, okay, it's not negative 3 feet, it's just 3 feet in that direction, right? This is just a distance of like 3 numbers from 0, whether it's whichever direction you're coming from. Okay, and so that's kind of the key thing is the absolute value of a number is non-negative. Okay, it's never going to be a negative value. Okay. So to kind of continue with this, if I say the absolute value of some number x is 3, okay, what would x equal? Okay, and we can kind of use what we have right over here. Okay, this means that x could be 3 or negative 3. Okay, there's 2 answers in this situation. Again, think about it. If we plugged in 3, the absolute value of 3 is 3, right? We set that here. And the absolute value of negative 3, if we plug that in for x, it's also 3. Okay, so these are both correct. Okay, and this idea right here is really important in seeing how and why we solve absolute value equations the way we do. Okay, because let's start with this example. We have the absolute value of x minus 18 equals 5. Now, think about it in relation to what we just did here. Okay, what's inside the absolute value here, this x value, okay, was either 3 or negative 3, right? The absolute value of 3 or negative 3 equals 3. Okay, so that means whatever's inside the absolute value here, okay, needs to equal 5. Okay, well that's 5 or negative 5, right? Whatever's on the inside here, if it was just 5, that would equal 5. If it was the absolute value of negative 5, that would equal 5. Okay, might be kind of confusing, but basically what that means is there's going to be a case 1 and a case 2. Okay, case 1 is when A equals B. Okay, and the A is what's in the absolute value bars, and what it equals is, in this situation, 5. Okay, that's our B. Okay. And so with that, we just kind of drop the absolute value bars, keep the x minus 18, and it equals 5. Okay, notice how all we did for case 1 is just get rid of the absolute value bars. We didn't change the sign of anything. All right, and we can solve this. Okay, add 18 to both sides. We have x equals 23. Okay, not too bad. Again, all we did was drop the absolute value bars. Case 2 is when A equals negative b. Okay, and again, all we're doing is dropping the absolute value bars on the left-hand side. Okay, so I have x minus 18. But now it's going to equal the opposite, okay, negative b. So this is now going to be negative 5. And again, you might be wondering, where did those two values come from? Again, remember, the absolute value of 5 is 5, and the absolute value of negative 5 is 5. Okay, we're solving for 5 and negative 5 in here. Okay, here we already solved for 5. Over here we're solving for negative 5. Okay, we solve the exact same way. Add 18 to both sides. We have x equals 13. Okay. With all absolute value problems, we should check to see if both answers work. Okay, so that means I'm going back to case 1. I'm going to plug in x equals 23. So I now have the absolute value of 23 minus 18 equals 5. Again, we're checking to see if this is true. Okay, 23 minus 18 is 5. So the absolute value of 5 equals 5. That is indeed true. Okay, let's go to case 2. Now we're plugging in 13 for x back into my original. Sorry, I should have made that clear. Okay, I plugged my x equals 23 back into the original problem. That's true. Now I'm plugging x equals 13 back into the original problem. Okay, so the absolute value of 13 minus 18 equals 5. Again, we're testing to see if this is true. 13 minus 18 is going to give us negative 5. So now we have the absolute value of negative 5 equals 5. And again, that is true, right? Negative 5 has a distance of 5 away from 0. That is also true. So both of these answers are correct. Okay, there are two solutions. Okay, the solution set is what we refer to it. You could write it like this. The solution set is 13 and 23. Okay, a set of numbers, this goes in a curly bracket. Okay, we talked about the set of real numbers, set of integers, whole numbers, natural numbers. Okay, this is just a solution set to this problem. Okay, let's go to another example, kind of a little bit different though. The absolute value of x equals negative 5. Now take a second and again think about what the absolute value of a number is. Okay, we're trying to find out what x equals. Your first instinct might be, well, let's try 5. Okay, well again, if you want, again, we're seeing how many the distance is to 0 from 5. We're trying 5. I'm not being your first thought. Okay, again, 5 is 1, 2, 3, 4, 5 numbers away from 0. And it's really important that I'm saying 5, positive 5, and not negative 5. Okay, even though yes, we did move in the left direction. Okay, distance is non-negative. Okay, so we just moved 5 spaces to the left. We didn't move negative 5 spaces to the left. Okay, so this is not correct. Okay, if you plugged in the absolute value of 5 does not equal negative 5. Trying to distinguish my absolute value bars from ones. Okay, well your next guess might be, well, let's try negative 5 then. Okay, absolute value of negative 5. That's got to equal negative 5, right? Okay, so you might be questioning me already, but let's go ahead and draw this on our number line. Again, if we start at negative 5, we're moving 1, 2, 3, 4, positive 5 numbers. Okay, and again, it's positive 5, right? It's not negative 5. Okay, so this is not equal negative 5 either. Okay, remember what I said earlier. the absolute value of a number is non-negative. Okay, there is no solution to this problem here. No solution. No solution. Okay. And if we're thinking about it here, right, remember we had a solution set. We had a set of numbers. We had two numbers here that worked. Okay, here we don't have any numbers that work. There's no solution. Okay, and there's two different ways you can represent that. You can have an empty set. Okay, just curly brackets with nothing in there. Or the way I prefer, because I mess up my curly brackets a lot, is just showing this 0 with a line through it. Okay, no solution. Okay. So far we've had a problem with two solutions. We've had a problem with no solutions, or no solution. Okay, guess what's going to be next? Okay, I'll leave you hanging on that. You can keep that thought to yourself. Okay, let's do one last example. We're going to address a few important things in this example. The absolute value of x plus 6 equals 3x minus 2. Okay, this problem, it looks a little bit harder. That's okay. There's just a little bit more on the right-hand side, but it's no different than any problems we worked out so far. Okay. Notice how on the left-hand side we have just the absolute value. Okay, and that's what we want. We don't want anything else. If, for example, there was something like this. Okay, a completely different problem. Okay, but notice how over here on the left-hand side, there's the absolute value of x plus 6, and then minus 2 outside the absolute value. Okay, in order to solve these absolute value equations, we want just the absolute value on the left-hand side. Okay, and we don't panic and say, oh, we can't do this anymore. No, okay, we can use our algebra skills and just add 2 to both sides, and then work it out the same way we're about to work out this problem. Okay. So again, you want the absolute value part of the problem by itself on one side before you continue with your case 1 and case 2. Okay, that's what we're going to do. We're going to start with our case 1. Again, remember this is when A equals B. Okay, your A is what's inside your absolute value bars. X plus 6 equals B. We don't change any signs. Equals 3x minus 2. We're going to solve for x. I'm going to subtract x from both sides and add 2 to both sides. I'm doing it all in one step. You can do it in multiple steps if you need. Okay, those are going to go away. We have 8 equals 2x. Divide by 2 to both sides. We get 4 equals x, or x equals 4. Okay, I'm not going to circle it yet until we check just to make sure. Again, get in the habit of checking your answers when it comes to absolute value equations. Okay, case 2 is when A equals the opposite of B, negative B. Okay, again, A is the same. We have x plus 6 is equals the opposite of B. Okay, we're changing the sign. Okay, so instead of 3x minus 2, it's now negative 3x plus 2. Okay, again, notice how I just changed the sign. This is a positive 3x. Made it negative 3x, which is a plus 2, or minus 2. I made it a plus 2. Okay, that was just for case 2, I changed the signs. Okay, now again, I'm going to solve for x. I'm going to add 3x this time. And subtract 6. X plus 3x, which is 4x, equals 2 minus 6, which is negative 4. Divide by 4 from both sides. I get x equals negative 1. Okay, again, let's check our answers. So I'm going to take my x values that I got and plug them back into the original problem. Okay, I'll do that in different color here, because I know there's a lot going on. Okay, Okay, I'm plugging it back into here. So I have absolute value of 4 plus 6 equals 3 times 4 minus 2. Okay, well 4 plus 6 is 10, so the absolute value of 10 equals 3 times 4, which is 12, minus 2 gives me 10. Oh, 10. Okay, and as we all know, the absolute value of 10 is indeed 10. That works. It's a check mark, believe it or not. Okay, let's now, so x equals 4 is a solution. Let's check our other possible solution, x equals negative 1. Again, do this one in blue. Okay, I am plugging it in to the original problem for x. Okay, so I have the absolute value of negative 1 plus 6 equals 3 times negative 1 minus 2. And I made this too big. I didn't have space. Minus 2. Okay, so the absolute value of negative 1 plus 6 is 5 equals 3 times negative 1 is negative 3. And my minus 2. Absolute value of 5 equals negative 3 minus 2 is negative 5. Okay, and right here, right away, we should realize that the absolute value of any number cannot be negative. Okay, so this is not a solution. X equals negative 1 is not a solution because, again, the absolute value of 5 is positive 5, not negative 5. Okay, you can never get a negative answer when you're taking the absolute value of something. Okay, so here there's only one solution. X equals 4 is our only solution. There's only one solution, okay? So we saw a case with one solution, no solution, and two solutions. Okay, that's a wrap of the video. Thanks for watching.